Why is it important to be able to find the solution to a system of equations in more than one way? Yesterday we found the system of equation solution by graphing, where we graphed both lines and we saw the point where they crossed. In this case, we're going to solve it by substitution, and where that you use math and your skills at solving equations rather than actually graphing. So our first one that we're going to use is going to be y equals 2x and y equals x plus 5. This is going to be our first system that we do. Now our steps to solve the first step has actually already been done for you in this problem. This first step is solve one equation for one variable. So for example, putting it in y equals mx plus b form. So for example, putting it in y equals mx plus b. Okay, you could also solve for x. In this case, both of our equations are already solved for y. So we're saying with this system of equation, y equals 2x, but y also equals x plus 5. So therefore, if y equals both of these things, then these two things also equal each other. So then I can set it up 2x equals x plus 5, because that's the same thing as saying y equals y. Well, I know y equals y. It's the same letter, but these also both equal y. So in substitution, we're taking the solution out of one equation and substituting in for y in the other equation. By doing that, I've eliminated one of the variables, so now I only have one variable. So that's step 2. Substitute the resulting expression. Substitute the resulting expression into the other equation. Okay, and that's what we did. We took the 2x and we substituted in for y. Now I'm going to solve. That's step 3. Solve for the remaining variable. So then I'm going to combine my x's to get all my x's on one side. So I'm going to subtract x from both sides. Bring down my 5. I get 2x minus x is x. So x equals 5. Step 4 is going to be substitute the value found into one of the original equations. Oh, sorry about that. Substitute the value into one of the original equations. So I'm going to go back up here, and I'm going to plug 5 in for x. So I have y equals x plus 5, y equals 5 plus 5, so y equals 10. So when x equals 5, y is going to equal 10. So step 5 is write the values from step 3 and 4 as an ordered pair. So write values as an ordered pair. Step 5, write the values as an ordered pair. Remember x, comma, y. I'm going to go back up to this problem, and I'm going to do, 5, comma, 10, and that would be my final solution. Let's do another example using these same steps. I've got 2x plus y equals 5, and y equals x minus 4. So step 1 told us to solve one equation for the other variable. Well, I've already got one. This says y equals x minus 4. So I've already done step 1. Let's do step 2. Substitute the expression into the other. Since y equals x minus 4, I'm going to substitute that x minus 4 in for y. So I'm going to take 2x plus y equals 5. Then I'm going to put 2x plus x minus 4 equals 5. I'm substituting in the value for y. Now I can solve. I've got 2x plus x minus 4 equals 5. 2x plus x is 3x minus 4 equals 5. I'm going to add 4 to both sides, and I get 3x equals 9. I'm going to divide both sides by 3. X equals 3. Now, step 3 said to solve for the remaining variable, which is what I did. This was step 2 where I substituted. This was step 2 right here. This was step 1. Step 3, I solved for the remaining variable. Step 4 is to substitute it back in. So I have y equals x minus 4. This is step 4. Then y equals 3 minus 4. Y equals negative 1. Step 5 said to write that as an ordered pair. So I'm going to put 3, negative 1. And that would be my final solution. Meaning that's the point where if I graphed both of these lines, they would cross. They would cross at 3, negative 1.